Well, thanks for coming, everyone. It's great. I know it's one of the last sessions of the day, so I appreciate you being here with me. Uh, Today, we're going to be talking about service principals and managed identity. If you don't know what these are, the whole point of this session is to explain to you what they do, what they are, and how you can use them, and why you should be using them, right? So my name is Christos. I work for Microsoft. Progress to my next slide. I'm a program manager for the Microsoft Identity team. I work in the developer advocacy. I like to join user groups, conferences, blogs, podcasts, whatever, to help inspire developers to write better and more secure software using our tools. I'm also a father and a husband. I love open source, and I'm also the Greek geek. So if you know any Greeks, then I'm one of them. Anyway, why are we here? We are here because we want to explain how we should be authenticating services today, especially in the cloud era, and how things have changed over the last few years. Why is this a pain in the backside? Because a lot of people try to do it and they don't always do it right, and it is something that I failed multiple times as well. And then we're going to look at what are managed identities and service principals in the Azure space, which are part of the Microsoft identity, and then how can we use them ourselves through demos and some slides. And walking out of this session today, you will know at least how and why you should be using them in your solutions and how they can help you write more secure software. So without further ado, if we were in the room together, I would be asking you to answer this question. How many of you here believe that you're identity developer pros? I would raise my hand. I see Duncan there is raising, waving his head. I know that not many people like to write identity. In fact, everybody hates identity. I don't know anyone that's like, hey, I'm excited. I'm going to write a login page today. It's going to be awesome. So identity is hard. Unfortunately, not many people realize how hard it can get, especially going beyond just a simple sign in, sign out, and what have you. And lots of people get it wrong. In fact, if you search for password reset in ASP.NET, one of the top answers that come on Google or Bing, whatever you use for searching, is one blog that contains such inaccurate information and so much insecure code. Like I highlighted here, like storing passwords in clear text and doing the password reset in such a wrong way that not only like people like Troy Hunt went and commented that this is not a good advice. But as a new developer, you do a search, you find something like, oh, that looks easy. I understand what the code is doing. I'm going to use this one. And guess what? Lots of companies, in fact, many companies that over the last few years have made the news. Every week we got somebody else making the news because they're either storing data insecurely, they're accessing data insecurely, or the front door, the sign in, sign out process is insecure. And I don't want you to be there. I don't want you to be one of these people. I want you to fall in the pit of success when it comes to working with identity. Now you might say, well, what does that have to do with managed identities? Well, we'll talk about that. Now, back in 2007, I wrote a system for a customer, and I hand-rolled my own artisan sign-in identity code. And guess what? This is what happens when you write an application and you put it in the public domain. You upload something on Azure or AWS or whatever, and then suddenly it becomes a target. You might say, well, I'm only writing a forum for my friends, right? Who's going to be interested? But you'd be surprised how many bots and tools and malicious code is out there running and scanning anything that has a public endpoint in order to find vulnerabilities. And your code or your data may not be the target, but your machine or your resources could become the Trojan horse that will allow somebody else to use your resources to launch attacks. So it's not always about getting access to your data. Is by providing a less secure front door, it means that other things could be compromised as well. So I've made the mistakes in 2007. And in fact, I spent days, if not weeks, if not months, trying to work out what is OAuth, how the flow works, why it works in such a way. How can I, create a password reset without compromising my users? How can I protect against brute force attacks? What happens if there's a rainbow attack? Where am I storing my data? There's so many different components that we don't realize today that could be used to compromise our solutions. So back then I was naive. Now I know better not to do it myself. And hopefully walking out of this session today, you'll know that you shouldn't be doing it yourselves either. Now, I work for Microsoft Identity, and we do have a couple of flavors when it comes to authenticating or allowing users to access a service and then allowing that service to go and pull information. Azure Active Directory, you'll probably love my awesome handwriting here. Azure Active Directory is one of these services that underpins identity for us. So with Azure Active Directory, which is neither Azure or Active Directory, it's an identity service that allows you to authenticate users and do a few other things. Allows you to go and register an application. You register an app that shows the intent of using Azure Identity as your identity provider. It usually comes with a client ID and a tenant ID. It says, this is the Azure Active Directory instance I want to use. And then we sometimes provide scopes, like I want to access Azure resources once I sign in, or I want to grab scopes for my APIs, or I want to go and call Azure services. In some cases, you may have to add a secret, the identity secret somewhere that allows your service to authenticate against Azure AD. So it's not just the users authenticating, but it's also the application identifying itself as the service. The problem there is that somehow we have to store that secret somewhere, and that becomes a target. Now, let's say 4 years ago when I was working with a customer, I walked in, and one of the things that we did was looking at OWASP and how their solutions were secure. And I said, how do you guys manage your secrets? Well, they said, we have an Excel spreadsheet that is password protected. I was like, okay, that's perfect. I like the fact they have a central location, but how do your applications consume API keys and connection strings and what have you? Oh, just put them in a web config. Okay. And now you might think, well, that's standard practice. That's what Microsoft has been telling us to do, or app settings.json, or configs.json, or whatever file you use for your solution, whether it's .NET or something else. The problem there is that let's say you know those secrets, and that's absolutely fine. They're secure. Like, you can secure your web config sections, so they can be encrypted when they're running on the server. Fantastic. What happens to those developers that have access to production systems? Think about that. You as a company trust your developers to write code and to access resources, but it's not uncommon for these developers to turn against the company, or to they're let go. Somebody was let go at the San Francisco Public Services. I think that he was working at the public transport. He got pissed off, but he got fired. Now, he was allowed to go back into his desk, so he sat there nicely. He encrypted the production database because he had access to that. And then that meant that he locked down all public services systems for San Francisco. So for about 2 weeks, everything was running for free because there was no way for the system to charge people that were coming in and going to the tram and other public services. Now, this guy was let go. They made the mistake to give him access to production systems, and then he was able to go and encrypt data. In fact, he was taken to court, and he was fined, and he was put in jail, but he never disclosed the actual secret, the actual decryption key. So they had to restore the system from some backup, and that took them 2 weeks. What I'm saying here is, by giving developers access to production systems or production code willy-nilly like that, can become a target. Or imagine if, as a developer, I'm testing locally on my machine, and my machine gets compromised. Now, I don't have any bad intentions of breaking production code or stealing data, but my machine gets compromised. I have the secrets in some file somewhere. Maybe that never makes it into production, but me having access to those things and these files and being available to my local machine, that also becomes a target for somebody else. And many times, most of the attacks are not launched externally. I'm not going to try to brute force GitHub to get access to your repo. I will go via one of your users that has something compromising on their machine that I can get access to, and then use their information to go and launch an attack to your, or scan your code, or launch an attack to your internal systems. So these ID secrets these are secrets that we want you to not have to worry about, neither as a developer or as a company. Yeah, that's the secret. And this is bad because how many times do you rotate data? In fact, I've been at customers that had production systems that were accessible by people that had left the company 2 years after they had left the company because they never rotated their secrets. Somebody had the admin username and password to some website, and they were able to sign in because these access to those systems were obviously was managed by an identity system that was not centrally managed, like Azure AD or some other identity provider. And the second one was like there was no good practice for actually rotating the secrets, and that meant that people had access to it. In fact, I did it. I was thinking about it last night. In my first job, after I graduated from university, I went as a tech support guy, and one of the things I thought was like, ooh, maybe we should be rotating our domain secrets, right? Domain passwords for our admins, because everything is running on a domain somewhere, and sometimes you need to have elevated permissions. And we had web apps that were running on our servers. Back then, we still had racks inside the office, so physical servers in the office. And I wrote a bash script that would go and increment the password every month to the month of the. So it was like some random word and then 01, 02, 03, 04, 05. So for every month, I was just rotating. That was my rotation. And it was easy to guess. So if you knew Monday, so if you knew January, you knew February and March. It was such a basic pattern. Always there was an exclamation mark in the end. So it was obviously more secure. But that was my rotation. I mean, that was better than not rotating the keys, but at the same time, it was an awful practice. So rotation is something that if you are managing keys today, you know how tricky it is. You have to remember how often to rotate them and when they expire and what have you. The other thing is exposure. Obviously, I did mention that. As a developer, I should not have access to production systems. You as a company, you don't want your developers to have access to production systems. Well, I still need to write code for that, but is there a better way? Absolutely. I will show you how. And that minimizes the exposure to you as a developer and the responsibility, and as a company. Scaling as well, like what happens if you have 10,000 users in your app today? How do you manage it when they come and when they go? If you have 10,000 employees accessing internal systems, if they're not managed by Azure AD, they have some random authentication attached to your solution. How do you manage those users leaving the company, right? And as I said, I've seen this happening before. And finally, it's definitely error-prone code. My bash scripts did not work well the first time, so I managed to lock out everybody, every admin account in the domain for the first month while I was trying to figure out why. I wasn't the best at writing bash scripts by then. I'm not better any now, but at least I don't have to do them anymore. I'm just saying that error-prone, and by error-prone, I also mean having access to production systems can also do major things. I had people wiping out production databases because they thought they were in the different subscription on Azure. So they went into there, let's wipe out the developer database. And obviously you can recover from that, but you have to raise a support ticket. It takes a couple of days. So, it's one of the things that we want to avoid people from doing. And security comes in layers. What do we recommend? What is the solution for against this? How do we protect you as a developer? How do we protect your company from malicious access? Well, obviously it's the managed identity solution. We have something called the Azure Managed Identity, which is an account that is managed by Azure AD and allows you to offload that responsibility of storing the secrets or the keys to something else. In fact, you don't even have to store secrets, right? Because Managed Identity handles the service principals for you. So service principal is a cloud account. I will explain that in a bit, but it does the secret rotation for you. So it's perfect. It offers simple abstractions from requiring tokens. So technically your application is saying, I'm going to use my managed identity to go and acquire a token from Azure AD behind the scenes. You don't have to do that. And then it will come back and provide me the access token to go and speak to my database or my storage account. It works like every other app or service principal on Azure AD. So you can actually use it in your code to do things as well. You can go and acquire the token manually. There's a well-known endpoint and what have you. It allows you to assign rights to service principals via RBAC, which means that if you are using a managed identity, you can say, I want this managed identity to only be able to go and get a key from Key Vault and nothing else. So with that, you don't have to worry about that account being compromised and then going and spinning up resources or deleting resources from wherever. It is available for many Azure services. In fact, I love because Azure AD underpins almost everything, and because managed identities are so important, there's a major effort driving let's make as many services compatible with managed identity as possible. So it started with web apps and storage and Key Vault, and then it expanded to support things like containers, Kubernetes, data lakes, SQL Server, and what have you. So you have your front end using a managed identity, and I will show you how it works. It uses a managed identity to go and authenticate against Azure AD behind the scenes. It acquires the appropriate tokens and then goes and speaks to the services that it needs to without you having to add anything. What does that mean? It means that my web app can speak to my SQL server without having a connection string, right? I don't have to provide a secret to that SQL server. I don't have to provide a secret to my storage account or my key vault. It will know how to go and do it for me. It is exposed as a local endpoint, which is fantastic. I can call it myself through code. I can do an HTTP call to that endpoint and it will give me my token back automatically, as long as I'm running at the context of that service. And it provides end-to-end security. Now, MSI or managed identity is not just used for what the docs are saying, right? Because the docs are like, oh, you can access services on Azure and that's all you need. But there are other things they can do. You can actually go and call into Graph and Office 365 and other services that are part of your tenants as a part of your organization. So it's a fantastic way to extend access to other resources securely. And the best one that we don't really talk about too much is the ability to actually go from your service, your front end, into another service that you own, another API, both secured with managed identity. So don't believe in docs, as the slide says, because the capabilities there are quite wide. You can do quite a few things if you want to, if you employ managed identity. How does it work, right? You have your application that needs to speak to another service, let's say Key Vault, right? Now I need to go and grab a secret from Key Vault, and I will show this in my demo using some kind of a connection. Now I only know where my key, all I need to know is where my Key Vault is. What managed identity will do, or my app will do, is go to Azure AD via MSI, call into Azure AD. Azure AD will issue the appropriate token with the appropriate permissions, and then I can go and speak to Key Vault as long as Key Vault is aware of that identity. If I am thinking about the other scenarios like Office and Graph and what have you, then I can use, again, a managed identity behind the scenes to go and grab my token. And then as long as my managed identity has the right permissions to go and speak to Graph or Office or SharePoint or whatever, then I can do that as well. And finally, the exact same pattern can be used for me to, from my application, my front end, say my single page app, written with TypeScript and JavaScript, can go and speak into Azure AD, grab the appropriate tokens, and then go and speak to my other service, my other API, which is also secured. And they will both be aware of that. They will both be able to authenticate the tokens and let each other speak. I don't have to configure anything beyond that. Let's jump into a demo because I've been speaking for the last 50 minutes and my voice is not the best. Right. So let's see what we have here. I'm going to be using a .NET Core as the example, but what I'm showing you here is not limited to .NET Core. You can use any of the Azure SDKs that we have available today, whether it's Java, JavaScript, Go, Python, Ruby, whatever you like, to actually achieve the same things. However, .NET comes with some nice features here. So I have a standard web application that has two things here. Obviously, I'm on my local machine right now. So managed identity is a notion that only exists on Azure, technically, but we are faking the managed identity. The libraries allow you to say, well, if I'm running locally, I still don't want to have access to the secrets. What I want to do, let me just make this bigger because I see that I'm struggling. And let me hide this one because that's totally relevant to what we're showing here. Hide. Let's go into our code. In fact, let's go to program. So what I want to do is I want to pull some secrets from Key Vault. This is what my code is doing here. But you'll notice that in my app settings, I have nothing with regards to where the Key Vault is or where, any secrets or any keys to my Key Vault. All I have here is just some logging information. So how does the application know what to do? In .NET, we have a couple of things. Let me show you the libraries that we're using. We have the Azure Identity that is responsible for authenticating the service. We have the Key Vault secrets, which allows us to go and at runtime, we can pull those secrets live. But we also have a configuration extension that allows us to bootstrap the solution. It allows us to bootstrap our solution with Key Vault. So when my .NET Core application is starting up, if I have something in my secrets, I have some config value from Key Vault, right? It's actually not a secret. It is a secret, but we don't want to populate this here. It could be left blank. At runtime, it was a startup at Bootstrap. it will replace whatever values here with what it finds in Key Vault. So if in my Key Vault, in my Azure Key Vault, which is a service that allows us to store secrets and keys, I have that same value, it will actually replace it on the fly and do it for us. And so I have these three libraries that I need to use. Then in my Bootstrap, in my program, one of the things I'm doing is I'm saying, as I'm building my config, let me hide this one and let me make the code slightly bigger. As I am bootstrapping my code, right? What I want to do here is I want to add my Key Vault. Now I'm pointing to my Key Vault, but you notice I don't have any secrets. And what I'm doing down here is I'm using the Azure Identity library to say, well, first I want to try my local credentials, which is my Azure CLI. And that can be anything. It can be your Visual Studio code. So right now you'll notice in my Visual Studio, I'm signed in as my domain account. That domain account, as long as it has access to Key Vault, it would also work. So I'm saying I want to use my Azure CLI credentials first. And if it doesn't find anything, I want to go and use my managed identity. As I said, managed identity does not exist on my local machine. But I will mention that. There's a nice caveat there. I could also be doing something like new Visual Studio credential, Visual Studio Code credentials. So I can, if I'm running inside Visual Studio, I can also use those. I don't have to use the CLI. And the caveat here is that as long as I have signed into my CLI and I have a valid token somewhere in my cache, then it will use that one to run the application. So that's the first bit. This one is going to bootstrap my application and populate the key there. Let me close this one. I don't want this one anymore. Don't save. And now there's another file I have, which is in the views, and we will see this running in a little bit, called Key Vault Secrets. And here, what I'm doing is not only am I pulling the config value, but I also want to, at runtime, go and get something from Key Vault. And to achieve this, the code is very, very similar. I have a secret client. It's a Key Vault secret client. It's part of the Azure SDKs. Right? And in here, what I'm saying is point to my Key Vault and then use the exact same credentials to go and get my credentials to authenticate to Key Vault and grab my value, which in this case is my KV secret. Let's see this running, by the way. Right? So let's spin this up. Terminal, new terminal. Right. Building, launch at the 5001. Just thinking about it. Where is the chat? I don't know if there's any chat. Where can I see my chat? Chat. Oh, I found it. Nice. No questions so far, which is good. Please let me know if you have any questions. I'm more than happy to answer them. So right now the application is running. Let's launch it. Launch. Check this out. Populated during startup. And then if I go to my secrets, hello MDC, oh, you rock. It should be you rock. But this is the information that is coming directly from Key Vault. Where's that Key Vault? Let's go and find it. Find the right window. There you go. So here, if I go into my secrets, session expired. Something about tokens authentication, right? So here I have my Key Vault and I have my secrets. So you'll notice that there is the KV secret I mentioned before, and there's the some config value from Key Vault. So as you can see, this one is running locally in my machine. I didn't have to have any secrets whatsoever. And then I was able to run it and authenticate against the Azure Key Vault. Now, if you were in an organization, if you're running code as a team, you'll probably have a number of Key Vaults. One would be a developer Key Vault, where you may have access to those secrets, so you can actually configure them and run them. And then in production, there will be another Key Vault where, in your application, you replace the hard-coded bad practice Christos Key Vault with some dynamic value that comes from your config. And then again, because that's not sensitive information, it can be something that can be stored in a config file somewhere. And then you say, when I'm running in production, I want to use a different Key Vault instance. So not always using the same Key Vault instance. And that allows you to see when the keys are rotated, who rotated them, why it happened. So if something is not working or it's broken, the Key Vault auditing capabilities allow you to go and find what's happening with your secrets. You can also find out who is reading those secrets and why they're not coming from your application if you only expected your application to be using them. So a lot of tight security. Now, what happens when I publish this to Azure? Like, how is this running on Azure? Because we said this is local, which is brilliant. Now I want to see how that manifest itself on Azure, because on Azure I don't have Azure CLI running in my service. Well, I could have a VM running Azure CLI, so that's a lie. Okay, let's see what happens when we go into Azure. So if I come here, I have this application was deployed some time ago. It's the same exact application. So if I browse into this, God, man, why did my sessions expire? It's fine. It's fine. Re-authenticating. It's good. It's about security. So in my overview, if I browse to my website, it's exactly the same. I could also go here and change it. In fact, we can go and change the secrets, so I can prove that I'm not lying. Let's see, new version. Now, because I don't want to mistype it, I'll say change dynamically. I'm gonna copy this. I don't trust myself to type in the blind. I will create that one. So you see that's the current version now. So if I go back to my application and refresh the page, check that out. Change dynamically. It's working, right? So this is my web app running in production using managed identity to go into Key Vault. No secrets whatsoever. So how does this work? Obviously, for the website to be able to do that, we need some kind of identity. It's something that identifies this exact instance to Key Vault. And this is my identity, right? Inside certain services, and as I say, more and more services are becoming aware of that, get the ability to have an identity. That identity has two flavors. There's a system assigned, which is something that you can provision as part of your resource, and it's tied to your resource as well. So if I were to wipe out this website today, it will automatically kill off my managed identity. It's nice, right? It's short-lived. The keys are managed by me. I just said on and save, and when it created everything for me. So this identity, if I were to go into my Key Vault, I should be able to find it in my permissions. So if I go into the root and I go into my access policies, this is where I define who has access to my Key Vault. I should be able to find it somewhere here. This is the same one. So this is the identity that we're currently running the website under. And you know, so it picked up the same name, which is great. I can easily identify that. And it only has two permissions. It has the ability to list and get secrets. That's all it has. Can't create secrets, can't change anything else, which is brilliant. It's locked down. And that identity, which is tied to my web app, can now go and access things. Now, in some cases, you might say, well, I don't want my identity to be assigned and only live with the resource, because that's the system assigned identity. I want it to be something I define, because I might be sharing that identity with other services, or I might want to have somebody else in the IT team assigning those identities to me, and then me as a developer just tying the two together. So in that instance, I could go and actually add an existing one here, and then let the website run under that identity. Easy peasy, right? So managed identities allow us to have one service calling into another service, whether it's our services or Azure services, and authenticate against them, grabbing a token and being able to pass the token and authenticate the token. And we don't have to share any secrets anywhere, which is brilliant. Now, the other piece of my talk, it's focusing on service principles, and this is usually a tricky subject or a contentious subject. So as I said before, I was working for a company. I had to manage the domain accounts and the local accounts and what have you, but it was all nice and easy to work with because I was in my own network. We had a LAN, we had the main service, we had an Active Directory, and I was managing all the accounts from there. And that was brilliant. But you know, at some point, everybody moved to the cloud. So suddenly we don't have that mode. We don't have that network. We don't have that kind of domain where I manage everything. And that became tricky because how do you create a service accounts that need to run services, right? I need a function or some web job or some daemon service running on a VM being able to call other services securely. In the cloud world, this doesn't exist. So how do we make it happen? Well, this is where service principles come into play. I talked about app registrations a little bit, and this is where it gets confusing. So an app registration always creates a service principal behind the scene. So I go into Azure AD, I create an app registration, that also creates a service principal. That service principal is the account that runs behind the scenes. And you can think of an app registration as the base class, and then the service principals as the instances of that class, where I can go and have copies of that. The nice thing is that I can lock the permissions for each service principal independently of each other. So I can have one service principal that maps to an app registration that has slightly different permissions to another. No. So service principals are your service accounts for the cloud era. They allow you to create automated tasks for PowerShell or CLI. They even allow you to sign in as these accounts when you need to run things. You can pass them into your daemon apps, and these daemon apps can authenticate based on that account from Azure AD and then acquire the appropriate tokens to go and speak to other services. You can use them for CI/CD. I will show you today how to use them. And then we have machine learning and every other service that supports these capabilities. So you can write, let's say, a Python task and upload into a service and run under that service principal, and we'll only have certain permissions, which I love. So the easiest way to create it is through the CLI. You can do it through PowerShell. You can do it in the portal. But first, you create a service principal account, and you give it a name, and then you go and assign it certain permissions. Now, the nice thing here is I can lock it down to a very, very small subset of resources. In fact, it can be at the subscription level, it can be at the resource group level, or it can be at the very specific resource level. So I can have a service principal that can only speak to a storage account and a very specific storage account within a within a resource group. And in that there, maybe I can only give it permissions to read the blobs and nothing else. So that's very nice as we can lock things down ourselves. Now, one of the things I really love about Service Principal is that it allows me to create CI/CD tasks that run securely. And I have a couple of demos for you here. The first demo is in Azure DevOps. And I don't know how many of you here use Azure DevOps, but it is one of the options if you want to run something in like CI/CD, right? I upload my codes and my repo is here. In fact, I only have infrastructure as code here. So I'm using ARM. And then inside my ARM, I have a template which only does a SQL database deployment. So it has my parameters, if you haven't seen them before. And then in here, it says I'm going to go and create a server and add a database. And this is nice. The problem is that for creating a database or for creating a SQL server, you need an admin login and an admin password. And it's been many times when I walked into a company and I saw this. Hey, we're using ARM, we're doing our deployment. And I was like, okay, where do you store your secrets? In the ARM templates. But they're inside Azure DevOps. Why would that be a problem? Think about that. We mentioned this before. As a developer, as an IT admin, as a DevOps person, I should not have access to production secrets because that allows me now to go and manage that SQL server somehow. And you might say, well, how do we manage these things? Well, you can still have secrets, obviously. You can still have the username and password, but we recommend that only very few people have access to that. You use the break glass approach where you have a vault, a physical vault in your company that somebody has to physically go and open with the right combination, pick them out and crack the keys so they can have access to them. That kind of security we're talking about. Now, I don't want to see you ever doing this. What I want to see from you guys doing is this, using Key Vault. Check this out. I can actually say at deployment time, go and grab my secrets from Key Vault, populate my parameters, and then pass these parameters into my ARM template to make it happen. And that means that I don't have to worry about that. Again, we're using the same kind of secrets. And then the way that this works is if I go into my YAML file, in here, what this YAML file is doing, in effect, is saying go and deploy this ARM template with the parameters. Well, this is the insecure one, so we want the secure one here with the Key Vault parameters that come in from this file. And for the task to authenticate, I'm using a service principal. So that service principal, luckily, DevOps will instantiate one for me. So if I say I want to create a connection to my Azure, then it will say, well, let me create an account for you. So in the settings, it's in the service connections. And this service connection, this CM internal, also exists in my Key Vault. It might have a deployment principal here, right? Different name, but this is what is doing in fact, I think it's this one. This is the one that actually authenticates to Azure AD, acquires the permissions to go and speak to Key Vault, and then comes back and runs my task. I'm not going to run the task because it's going to take 5 minutes, but I want to show you something else, right? You said, Azure DevOps works great. Thank you. But you know, we're running on GitHub. Fine, GitHub. In fact, you can be running on anything. You can have Jenkins, you can have any other tools that you want to work with. But I have my repos. Should load this before, but it's fine. So here, I have a very similar task. I have my GitHub action, and inside my workflows, I have a main. So my main does the exact same thing, although it's using GitHub to deploy things. So what I have here is I have my branches. I'm pulling from main, the exact same code. And then down here, I am authenticating with the Azure CLI. So I'm grabbing the appropriate permissions. But in this instance, I'm not using my own account. I'm using a service principal account, which I created and assigned to this GitHub repo. And then from there, I'm deploying things using that account. So this one is deploying my ARM templates. You'll see it's using the Key Vault version. And I don't have to pass secrets anywhere at all, which is awesome. But the other option obviously would be to, you can do it with Terraform as well. So let's go and see how Terraform works. By going to my root, I have another deployment option here. And then in my Terraform, I have my variables, which are not secrets, right? Resource group is not a secret, or the location is not a secret I need to protect. But I also have a SQL Server I need to deploy, and I need to have some kind of a way to protect them. So my admin username and my admin password are using the Azure Key Vault provider to go and grab the secrets. So I'm instantiating this with Terraform. Then I say to my Terraform, go and use my service principal account and securely go and pull these two secrets from my Key Vault. And then down here, I'm passing those secrets into my deployment. So you can see Azure DevOps, GitHub, GitHub Actions, and then Terraform can all benefit from removing all the secrets altogether and managing them. Now you might say, well, Chris, it's fine. I mean, we can stick them into our secrets here, right? The challenge here is that you don't really have auditing on who's using the secrets and when. Whereas if you do it via Key Vault, you know exactly how often and when and by what secrets are being accessed. Now, I had to put Azure credentials here because it is the lowest denominator I could have, the minimum denominator I could have to store things. However, me and my partner have JP, that we work in the same team. We wrote an Azure CLI extension that allows you to remotely run these GitHub actions and not have any secrets because they're using the managed identity of those of that machine. So right now here I have here I have a Linux VM that has the task running, and if I wanted to find my endpoint, you'll notice that I'm saying here, go and find me the managed identity that is currently assigned to this machine, and go and grab the token for me. And if I were to look into this token, then let's grab this. Let's go into jw2.ms. And then here, if I paste this, you'll notice that it came from my Azure AD. The audience is management Azure, so I can go and deploy things to Azure. And it has all the things I need in order to be able to authenticate and run that managed identity. So I also have a job that is pointing to that remotely. So if I go back into my GitHub, is this the one I came from? No, GitHub, here. So here I have, back in my code, and I know we're almost out of time. So inside my deployment, inside my, oh no, sorry, it's one level up. It's in my workflows. I have a remote workflow. I think it's this one. And in here, what I'm saying is, rather than using my local, the hosted one, I want to use a self-hosted service that runs on my VM, my Linux VM. And then I'm using a different flavor of that login, which is going to make it into the main repo. So eventually you won't have to use the custom flavor of this login. But this will allow you to use the managed identity and deploy things. So again, I should be able to grab the secrets from there, authenticate, and then run any tasks I want against Azure. So managed identities as service principals allow you to do quite a few things. In effect, I call them secretless apps and secure DevOps, because you don't have to worry about storing secrets in your application and configs. You don't have to have secrets files somewhere in your machine. You as a developer don't have to worry about that. Somebody in the IT team will manage everything for you. And then you can run all the tasks that you need in Azure by removing all the secrets. So there you go. You should start using Service Principals in Azure AD. Is it 45 minutes or an hour ahead? I can't remember. It's an hour? Okay. So what did we learn today? That authentication is hard, but we make it easy for you. Hopefully 1 hour. Okay, good. We have 1 hour. Perfect. The masked identities are great for end-to-end security, right? So that means that again, as I showed you, you start with the Azure Identity Library. So if you haven't used the Azure Identity Library or you haven't used the Azure SDKs at all, the easiest way to get started is by going into here, ak.ms, AZ SDK. And from here, you can choose the language that you want to use. We have .NET, Java, JavaScript, Python, C++. So everything I showed you today is applicable to all the other services. The key library here, obviously, is identity. This is the one that manages the authentication component inside your library. And then from there, all the other services that we have, as you can see, we have cognitive services. In fact, I did a demo the other day. We stream quite a bit on Twitch. So I did a demo the other day where I showed you how you can write a .NET Core app that speaks into cognitive services using Azure AD to authenticate things. So as long as you have an Azure AD backed up cognitive service, because you have to deploy that, you have to have a custom domain. There's like a limitation there. You can actually go and call most of the services using masked identities, which is great. One thing that doesn't cover masked identity yet is Cosmos DB, and that's because there's a requirement for the SLAs. We have a very, very tight SLA. So doing a round trip to Azure AD to get a token and come back means that doing a call to Cosmos to authenticate via Azure AD would slow things down. But we are working towards enabling that and lightening that up inside Cosmos DB as well. So if you say, well, I don't really want sub 9 millisecond performance, I'm okay with 12 or 11, then you can use Azure AD to back things up. So that would be an option to you in the future. I think we are working towards that. And then storage and everything else can also be backed up by Azure Identity, which is great. Let's see, what else? So we have the Azure SDK. I talked about the how you enable them. I told you how to spin up one. So in fact, let's go into the CLI. There you go. AZ, CLS, clear. Sorry, I'm in a Linux VM, so I need to remember my commands. So here, if I were to create a new service principal, AZ, AD, SP, create, that's us for our back. I think it's my name. We need that. And we'll say NDC London. What did I do wrong there? I'll go help. There you go. Why not? Okay. It was create for our back. I mistyped our back. There you go. Our back. And I need to sign in, obviously. Sorry, guys. First, before I use that, I need to sign in. So there you go. Let's authenticate. You know what? It would be easier if I do it inside the portal. So if you haven't used the CLI before, rather than doing it in the remote VM, because now it will be out of context, what I'm doing here is requesting Cloud Shell. If you haven't used Cloud Shell, it's the built-in CLI or PowerShell that we have for working with Azure. The nice thing is that I can authenticate it, so I don't have to do it from scratch. Connecting to it. And now I can do AZ ADSB creates. For real? God, not my morning. So now this one is giving contributor rights to my whole subscription, which is not good. But you can go and change the role assignment afterwards. The nice thing here is that it created everything I need. You notice that it actually gives me a password. That password, it will be rotated for me. I can go and change it if I want to. In fact, I should change it. In fact, I will delete the whole thing. But it created an app ID for me. So now I can take this one and start using it everywhere I want. If you were to use it inside something like GitHub that I showed you, you have to also say that's SDK auth, and that will create a different SP type, which will be, you'll notice that the output is slightly or somewhat different. There you go. Thinking about it, trying to do the role assignment. Again, it will be a full contributor to my whole subscription, which is not best practice. You can say, you can define exactly which scope you want to give it. Eventually we'll come back. Any questions with regards to mass identities or like a lot more information here now, right? So your client secret, client ID. In GitHub, I would grab this whole thing and add it as my Azure credentials. So I don't know if anyone here has used service principals or mass identities, but I hope that it gave you a nice insight on why you should be using them and how you can get started with them. And which libraries to use. Obviously, you don't have to use the libraries, but libraries make your life a lot easier. So the SDKs that we have for Azure make your life a lot easier. And the reason why I'm saying that is because for everything to start with, you need a token credential or a credential provider. And there are options here. You can use the default Azure credential. And with that, you don't even have to say what you're going to use. You will try one at a time to find the signed in credential. So we'll try to find the mouse identity. We'll try to find the other ones. So as soon as it finds one that is authenticated, then you're good to go. One thing that we didn't have enough time to cover yet was, right, I have mouse identity in the cloud. I have my local identity running on my machine. We have service principals running tasks. But what if I wanted to actually use mouse identity on a machine that is not part of Azure? Because we've been talking about Azure. Azure Arc, which is a service that allows you to add machines into your tenant and make them look and feel like actual Azure VMs, is a service that you can run anywhere. So you can have a VM running on AWS that needs to access Azure services via managed identity. I could have my local machine being Arc joined into Azure AD, and that allows you actually to not only be part of the Azure, but also have a local managed identity instance, which means that in AWS, you can have a task running like this, authenticating against Azure AD, and then calling Azure services without you having to pass any secrets. So Arc is the extension of all these things that we talked about that bring the Azure identity component into any machine. So rather than using my local CLI credentials, if my machine was joined into Azure Arc, I could just, and it's a very simple task. You run a PowerShell script and we'll attach it to Arc, and Arc allows you to manage that device as if it was inside Azure. And the whole point there is that you get the benefits of having a VM managed by Azure and that identity available to you, which I find it's a great extension to everything that we talked about, because you can go outside the Azure ecosystem and still be part of the Azure family. So there you have it. We covered everything that I wanted to cover today. If you have any questions, feel free to reach out to me on Twitter. Feel free to reach out to me on email. In fact, I can send you my contact information if you want to. I will add them to the chat. And if you are working with Microsoft Identity, if you have any questions about how to work with our technologies, then I'll be more than happy to help you out. We also have a stream that we do every Tuesday and Friday at 8 a.m. Pacific time, where we show you how to build things like that. If you are into Twitch, if you are into stream, we're on YouTube, on Twitch, and we have everything on YouTube as well after that. We talk about how identity can help you write more secure solutions, whether it's authentication, authorization, DevOps, security, other services. We cover everything. And if you have ideas for the show or questions, feel free to join us. I appreciate everyone for coming. I know it's the end of the day. For some of you, maybe quite late in Europe. So thank you very much for attending my session. I'll share the slides. The demos are actually live on YouTube, sorry, on GitHub. So if you go into GitHub, you can find all the demos here. We have blog posts as well that explain how to do things. So it was great. Thank you. It was nice being part of the NDC as well. And I appreciate your time. Thank you very much.